Dear students, in the last video, we discussed about basic morphological operations. We discussed about what is erosion, dilation, and also we have seen the examples of erosion and dilation operations. So in this video, we are going to discuss about three important topics, that is opening, closing, and hit or miss transformation. So opening and closing, they are again two important morphological image processing operations. So first we are going to start with morphological opening operation. Opening generally it is used to smooth the contour of an object. The opening operation mainly it is used for smoothing the contour of an object. It is denoted by using this particular symbol. We use a simple circle to indicate the opening operation. Opening of A by B can be defined by this particular equation. If I write A circle B, it indicates opening of A by B. As we discussed, A is called original image. It is the original set we can say, and B is called as the structuring element. So opening of A by B can be defined as erosion of A by B followed by dilation of the result by B. So if you look at the equation, easily you can understand that opening of A by B is erosion of A by B. Followed by this, we are going to dilate the structuring element B with this first result, that is erosion of A by B. First we carry out, followed by that, whatever the result we get from erosion of A by B, it is dilated by B. So this operation we call it as morphological opening. Okay, here we are going to look at how this opening operation works. So opening operation can be thought of as rotation or rolling of the structuring element inside the original image. Okay, here we have a very good example to understand the concept of opening. Okay, assume that this is the set A, that is original image A, which is a triangle we have, and we have a structuring element which is a small disk. We have a small circle which is considered as a structuring element. So actually when we apply opening operation, what happens is this structuring element circle in this case, it will rotate throughout this object within this triangle inside the triangle, rolling of this structuring element takes place. So that if this structuring element, that is a circle, rotates within this triangle, the result is smoothing of contour of this particular object triangle. So this will be the result. Okay. Okay, if you look at this diagram, we have structuring element B, which is rolling along the inner boundary of this A, and this dot indicates this dot, and even these small dots, they indicate origin of this structuring element B. Okay, so this is the result of opening operation. Okay, the next, similarly, we have closing operation, and the closing operation is represented by using this symbol. To represent closing operation, we use again shaded circle. However, opening was represented by using a simple circle, but here closing operation we represent by using a shaded circle. Uh, closing of A by B, closing of A by B can be represented by this particular equation. It is nothing but first dilation of A by B followed by erosion of the result by B, so that the closing operation can be obtained first by carrying out dilation between A and B, and whatever the result we get, on that result we are going to apply erosion of B. That is, we are going to erode this result. We are going to erode this result by the structuring element B, so that the closing operation can be defined as dilation of A by B followed by erosion of the result B. Okay, here we have geometrical interpretation of this closing operation. The closing operation can be thought of as rolling of this structuring element outside the boundary of original image A. So here A is again the original image. This B is the structuring element. When we apply the closing operation, it is as good as rolling of this object B, rolling of the structuring element B outside the original image A. So the result of the closing operation will be like this. Here we get the closing operation result. Okay. So in generally we can expect opening and closing operations. They are dual to each other. They have duality property. Okay, here we have one more classical example of opening and closing. So in many of the image processing operations, opening and closing, they are used to enhance the quality of the image. Okay, if you look at this first diagram, it's a fingerprint impression we have. It's a noisy image. Okay, so to enhance the quality of this image, we can use a set of operations. We have first a structuring element. First, what we do is we use this noisy image. This is the structuring element P. Then we are going to apply erosion. Followed by that, we have used opening of A. Then we apply dilation of the opening operation. Then again we apply closing. So actually, this is one of the experimental result when we carry out these steps in this particular sequence. In this particular sequence, we can find that there will be an enhancement in quality of the input image. So actually, the erosion, dilation, opening, and closing, if we apply in a particular sequence, it is possible to improve the quality of the image. So this is all about opening and closing. Students, again on this topic, you may expect one question like explain or write a short note on opening and closing. So in that case, first you write the equations and write the definition. Write the statement corresponding to opening and closing. And you have to explain with the examples. Okay, next we have one more important topic called hit or miss transformation. We have one more important question called hit or miss transformation. So this particular transformation, it is used to detect location of shape in an image. If an image contains a lot of shapes, the location of a particular shape can be obtained by using hit or miss transformation. This operation can be denoted by using this particular symbol. That is, we use a cross symbol. We use the multiplication symbol within the circle, so that this particular operation indicates hit or miss transformation between A and B. The hit or miss transformation between A and B with B equal to B1, B2 is given by this particular equation. This entire equation is indicating the hit or miss transformation. Okay, if you look at the equation, we have an intersection between erosion of A by B1 and erosion of complement of A with B2. Okay, let us consider A is having three shapes X, Y, Z. We'll take an example to understand this concept. Assume that you have a set A with three different shapes, say X, Y, z of different size. Now assume that the objective is to detect the location of the object x. The objective is to detect the location of shape x within the set A. Okay, here we have the example, right? Assume that this is the set A, which has three different shapes, say C, D, and E. Or assume that these are X, Y, and Z. Okay, the objective is to detect the location of one of the object. Okay, the first step is we are going to erode A by X in the equation. In the equation, B1 is equal to X. The objective is to detect location of X. So in place of this B1, we use the shape X. The second structuring element is B2. So actually B2 indicates the background of X. The background of the shape X is nothing but we can say B2 in this particular equation. And what we do is we erode complement of A by B2. First step is we are going to apply erosion operation between A and B1, where B1 is the shape or object whose location is to be found. Then next we are going to carry out the erosion operation between the complement of A and B2. So in the equation B2 is nothing but the background of the object B1. Then after that we are going to have the intersection between these two operations to get the location of the object say B1. Okay. Here we have a very good example to understand the concept. Okay, in this case, if you consider this diagram, the first diagram is going to indicate set A. Assume that this is set A, which has three shapes, say C, D, and E. And assume that W is the local background of object D. So in this example, we assume that we wanted to know the location of this shape D. In this particular example, the objective is to find the location of object this D within the set A. So here W is the background of this object D. Then as per the equation, first we are going to have W, which is background of D. Then we calculate W minus D. So W minus D is this particular example. Okay. Then after that, we are going to have the complement of set A. Complement of this set A is this particular result. Just we are going to replace ones with zeros and zeros with ones. Then after that, we apply the erosion operation between this W minus D with complement of A. This will produce this particular result. So when we apply erosion operation between complement of A and this W by W minus D result, we are going to get this part of the result. Okay. And finally, we are going to have an intersection between first operation, that is erosion of A by B1, and erosion of complement of A with B2, that will produce this particular result. So if you observe, we can find the location of this object D. Only the center point of the object D will be indicated by a small dot after completing the entire operation. This is about hit or miss transformation. Students, here you have to understand the operations step by step. So just you go through this example in detail. Easily you can understand how this will provide the result. Okay. So remember these three operations. whatever we have discussed in today's video. First one was opening operation. Opening, it is used to smooth the contour of an object. It can be defined as erosion of A by P followed by dilation of the result by P. And opening can be thought of as rolling of the structuring element inside the original image A. Then we discussed about the closing operation. Closing operation can be defined as dilation of A by B followed by erosion of the result by B. Then closing operation can be thought of as rolling of the structuring element on outer boundary of the set A. Then remember the opening and closing, they are dual operations. They are complement to each other. Then we discussed about hit or miss transformation. The objective of hit or miss transformation is to detect the location of particular shape or object in the image. So that you have to remember this equation and you have to explain with an example. So again, hit or miss transformation, it is very important from examination point of view. You have to write this statement, you have to write the equation, and you have to explain with an example. Okay, students, thank you very much.